So let's start this off, excuse me, by going over the severe threat today. This is the current radar. You see a very potent, a somewhat potent, I guess, mid-level low moving through the Mississippi Valley this morning with moisture streaming to the north here, heavy rainfall to the north as well. Um, right? Let me take the hazards off of here right now. Okay. And the focus of this discussion is just going to be on the severe weather, right? So um, let's take the radar off. We have a slight risk of storms here, severe weather, generally from Pensacola to Cordele, all the way down to Jacksonville, into parts right up on the Palm Coast here, um, Cedar Key, the panhandle of Florida, right? The larger marginal risk surrounding it, generally from Mobile, Alabama, to Selma, up to LaGrange, just north of Macon here, to Augusta, parts of South Carolina, and down towards Savannah. And points southward here also are at a marginal risk. And so that's the overall risk. General thunderstorms possible in the rest of this area today. So, tornado threat. The highest tornado threat, according to the SPC, is in this brown area here, 5%, surrounded by 2% risk in the large area we just outlined, right? Although based on what I'm seeing so far, I think either we're going to have the wind threat is the most prevalent threat further to the north here, but we'll see, right? Wind, you see the slight risk is driven by the wind risk here, okay? So the highest risk of winds exceeding 50 knots within 25 miles of a point is in the yellow area here, and then a 5% risk further to the north. All right, hail risk a little bit further to the south here in that 5% hail risk area, where the best dynamics will be and lift, but I want to rule out some hail in low points further to the north as the 500 millibar, the mid-level low, moves through today. So going back to the radar, we have something ahead of this mid-level flow here. It's enhancing the precip, excuse me, right now, and that's going to move through middle Georgia this morning with some lift associated with it down on the south end of this. And if we bring up the radar here, let's bring up the radar real closely to it. All right, and so storms moving to the west of it and to the east here, moving to the northeast right now. Mostly stratiform, looks like precipitation here with some embedded, maybe some embedded heavier rain moving to the north. We'll impact our area shortly, and it may come through before I even get a chance to post this. So, yeah. So, okay. So on to the analysis here. So this is HRRR, the latest model run, 10Z. All right, we have another. They run every hour, right, and they're 18 hours out. So showing the ongoing precip pretty well here, right, and what we anticipate go through time. That precip shield will move to the north here. A line of storms will move to the east here, with the possibility of severe weather where the deeper colors are here. Although I don't really see a lot of rotating updrafts with this, although embedded in a line here, you can see some potential for severe weather, right? And you had the mid-level feature moving through later in the afternoon, right? This is 6 p.m., 5 p.m., 6 p.m. Eastern, with potential for some small hail as we get some cool air, colder air aloft moving through, right? So generally right now we got that first push of rain, and then around 11, 10 or 11, we're going to have another push through with potential for severe weather. So when that clears out some, and then around 5 or 6 p.m., we potentially get some more enhanced upper level forced precip, maybe some small hail and lightning moving through. So, and that's like I said, around 8 p.m. this evening. One parameter we look at with this stuff, right, is a 0 to 3 kilometer cape, which gives us a good indication at the surface what the instability is here. And when we get three cape approaching these values, 160 joules per kilogram, that tells us that we have a lot of energy in the low levels of the atmosphere. If we go back to this, let's see, this is 21Z. Yeah, that's likely as a result of the upper level feature moving through. So that's after we get that initial push, right? So we have this initial push here, then we get this enhancement uh, as an upper level feature moves through, right? And moves to the northeast. And you have this enhancement as well down here to the south, right? So um, you see initially the highest 3 cape values are down here. So, and that's most likely why we have the severe threat is the highest, I think, into parts of the panhandle here. So another thing we look at in severe weather setups is the lapse rates at the lowest levels, right? And you see the lapse rates are pretty paltry here. Anything over 6C per kilometer um, is is conducive for severe weather. Anything below that, you have less likelihood, right? Because the lapse rates are pretty poor, right? And we both go through 3 p.m. here. Let's go back to 2100 with this. And we go back to the when the lapse rates are the highest, right? Yeah, so for central Georgia especially and pulling south, the lapse rates are the highest, and the surface-based cape is the highest as the upper level feature moves through, which um, let me switch to that real quick. So here's your 500 millibar low, mid-level low moving through, right? And you can see where the why the enhancement here, right? Because the this 500 millibar low is moving right through this area. Although it's filling and weakening with time, before it does that, it moves through, right? So bringing colder temps aloft. If we switch to 700 millibars real quickly here, you see right before it moves through, you have some pretty strong low-level winds as well. Go to 850, which is close to the surface. Ahead of that, you also have some enhancement of the winds there also. So that's one of the drivers as that mid-level feature moves through. You see the temperatures here at 700 millibars. They cool quite significantly as this mid-level feature moves through, which even though the wind profile is from the west, you have the cooling aloft, and that typically can lead to you know, can enhance some convection in this area, forcing, right? You look at the sounding here. Not a lot to look at here, but It may not pick this up very well, but let's go back to this here. Yeah, so this is the radar, when you get this far out. So you see what I'm talking about here. So what do I think about tornado risk here? So let's talk about that real quick. So one of the things we're going to look at here is surface-based CAPE and the photographs here in advance of this system moving through. Photographs look quite favorable, but not a lot of instability at the surface here. And when that does increase in middle Georgia and points north, that's because the mid-level feature moves through. So honestly, I'm not that bullish on a tornado threat. So because the surface-based instability is pretty much lacking here. So let's look at a few other parameters here. Some things we look at too is updraft helicity here, right? And 0 to 3 kilometer updraft helicity. You know, they have some swaths here into southern Georgia, into the panhandle of Florida, which is where the highest risk is, right? And maybe into central Florida here, into North Carolina, maybe into central Georgia, but not that impressive, right? So let's move to 2 to 5 kilometer updraft helicity, a little bit higher in the atmosphere. Uh, yeah, not that impressive either. Another parameter you look at is energy helicity index. This is 0 to 1 kilometer, and you see the values approaching anything greater than 0.5 or less than 0.5, and up and higher can signal the potential for tornadic storms. And we have a broad area here in the Panhandle, right? And that moves to the north, and then not a lot after that. So there's some areas of it, but yeah, the possibility is there, but I wouldn't say pretty small area here. And I would say this is the last parameter I'm going to look at, the 0 to 3 kilometer energy helicity index. When you have these parameters this high, that tells me, like in this area, the potential exists for tornadic storms, right? You have enough instability, and you have enough spin in the atmosphere, right? So I think the highest area for the highest threat would be generally in this area here as we go through the day today. This is at 1 p.m. So that's my thoughts on this severe weather threat. I hope you all get something out of this, and I'm going to include this as part of my regular forecast, but I wanted to put this out there before everything else.